So today we have a fun experiment. We're going to be looking at the differences between simple and fractional distillation for the distillation of a red wine. Here I have a Cabernet Sauvignon. It's approximately 13% alcohol by volume. And what we'll be looking at is the differences in the alcohol enrichment in the distillates for simple versus fractional distillation. Now, in lab, I'll demonstrate the glassware setup for the differences between these two. It's very simple. The main difference between a simple and a fractional distillation is that there's a column that sits between the distilling flask and the sidearm adapter, the distillation head. In fractional distillation, it gives essentially a longer path for the vapors to condense and re-evaporate as they travel upwards. And each condensation, re-evaporation cycle is essentially, each zone where that occurs is known as a theoretical plate and leads to enrichment in the lower boiling substance, which in this case turns out to be alcohol. So let's go up to the lab and see what we get.
So here we are ready to set up the distillations. Now, the setup for distillation, or the glassware that we require, is actually quite simple. We'll start with a round bottom flask, which is where we'll put our wine or the material we're going to distill. For a simple distillation, we simply take this sidearm adapter, shown here, and place that directly on top of the initial round bottom flask that we will be heating, the heating round bottom flask. Now, to this we will add a thermometer adapter, which is shown right here. It's got this little rubber piece on top that you can place a thermometer down through. I'll show that in the finished product. So we'll simply place this on top, and then the thermometer here could sit down through this. Now, it might be intuitive to place the thermometer down through the thermometer adapter all the way down into the liquid to measure the temperature there, but that could be misleading. Really, what we want when we're doing a distillation is we want to measure the temperature of the vapors as they traverse from this glassware here over into the condenser, which I will show next. So what we want is we want to put the thermometer down through just so that it's at the level of the sidearm right here, so we can measure the vapors as they pass over. Now, I mentioned the condenser. That's the next piece here. Got this condenser right here. Now, this will attach to the sidearm adapter here, and it has an inlet and an outlet. So there's a central tube that runs through, but then there's an outer tube that's a jacket. We can connect this inlet here to a hose running from a sink or from the faucet to run water in, and then another hose here that runs back to the sink for the outlet, or to a water circulator. And this allows you to chill this column, which then will condense the vapors as they enter it back into liquid, which will then drip down, and from here enter down into the receiving flasks. Now, the receiving flask is just going to be another round bottom, or it could be any kind of shape of material here, or any shape of glassware. You might be intuitive to just put this on the end of the condenser, but then if I do this, the entire system will be closed. There will be nothing open to atmosphere, and it's not generally a good idea to heat a closed system, because then you can get pressure buildup and have disastrous explosions or something along those lines. So we have one more piece of glassware we insert between the condenser and the receiving flask, and that is, here I've chosen a vacuum adapter. So there's a sidearm here that could be attached to a vacuum. Now, I'm not going to be using vacuum in this distillation, but it could be, and it essentially opens the system up to the atmosphere so that we don't get any pressure buildup. Now, to best illustrate this, I should show it to you all connected. But there's danger of pieces falling off and falling apart, and that's where one last very, very useful accessory comes in, and that is the Keck clip. So Keck clips here come in different colors, generally depending on their size. So blue happens to fit well with 1922 adapters. Green as well for 2440s, and yellow tends to work for 1420 adapters or for 1420 sizes. But it's very, very useful clips. It allows us to hold pieces of glassware together. So I'll take the receiving flask here, put it onto the vacuum adapter, and then clip that in place, and now that holds very nicely. I can do the same thing with the condenser and the vacuum adapter, so now that is held together. And then finally, I can take a couple more Keck clips here, make some connections on this side. So we'll connect the sidearm adapter to the initial round bottom flask, connect that to the sidearm to the reflux condenser, and now we have our system connected. Now I'll have to make a few adjustments here, but this is the system. Now, of course, we'll have our thermometer and the thermometer adapter. I will apply heat to the initial round bottom containing the solution. I will do that by placing it in a sand bath on a hot plate and turning on the hot plate. And then the other thing to really make sure is that I'm going to use clamps attached to ring stands to make sure that my system stays well in place. And that's essentially the setup for a simple distillation. I'll run the distillation for a while until I've collected some material in the receiving flask, and then I'll take that distillate and go measure the refractive index for it to get a measure of the alcohol content in the distillate. Now, we will also do a fractional distillation, and for fractional distillation, the setup is identical to simple distillation with one exception. So here, in between the initial round bottom flask and the sidearm adapter, I will insert what's known as a fractionating column. In this case, it's just another condenser that doesn't have a very large jacket on it. And I'm simply going to insert this between the round bottom flask and then the sidearm adapter. What this does is it extends the distance that the vapors have to travel before they get condensed in the condenser and then collected. What this allows for is that as those vapors rise up this column, they will establish various points of vapor-liquid equilibrium. They'll condense on the side of the wall and then re-vaporize. So we'll want to make sure that this whole column is insulated so that vapors actually can climb up and won't just condense on the side walls and never travel the entire distance. But as we do this, each time that you have a zone, and we often refer to these as theoretical plates, where a plate is a theoretical zone where you establish a vapor-liquid equilibrium. And each time that you condense and re-vaporize, it enriches the vapor in the more volatile or lower boiling component. So in just a simple distillation, when we first vaporize material, the vapor is composed of ethanol, the lower boiling, but then also water vapor as well as vapors of the various kind of taste components of wine. But then for each subsequent time when we establish a zone of vapor-liquid equilibrium, the vapor phase gets enriched in the lower boiling substance, which in this case is ethanol. And so by the time that we reach the sidearm adapter and then the condenser, that vapor should be enriched relative to the simple distillation in ethanol. And we should be able to see this by measuring the refractive index of the distillate from a fractional distillation. So that's the basic setup for both a simple and a fractional distillation. Let's put it together and see what we get. So here we are set up for the simple distillation. You can see that the thermometer has been placed through the thermometer adapter to about the point where we first have vapors crossing over into the sidearm. Now, I have not at this point added the solution to the initial round bottom. So to do that, I will remove the thermometer adapter, add a funnel, and then add approximately 50 milliliters of wine. Now, to avoid what's known as bumping, which is when we have a really uneven boil and you get large kind of splattering of material, it's helpful to add a stir bar to the system. So here I have a small stir bar that I will add just to have some even stirring in the solution, simply to provide a more even boil for the material or for the solution during the distillation. Here we have the distillate of our fractional distillation. So we'll take the refractive index and see what our alcohol content is there.